BYD doesn't just make electric cars, it makes the engine, the battery, the motor, and the factory that builds all three. While Toyota spent decades perfecting its hybrid system and Tesla bet everything on pure electric, BYD quietly built something neither of them saw coming. A hybrid engine so efficient, produced at a scale so massive that the entire automotive industry is now being forced to recalculate. And in this video, we're going inside the factories, the technology, and the step-by-step process that's making it happen. Subscribe now, because this is the kind of story you won't find anywhere else. Most people know BYD makes cars. Very few know where the engines inside those cars actually come from. The answer starts with FinDream's powertrain, BYD's own internal division, built specifically to handle engine production, electric motor assembly, transmissions, and full hybrid system integration. No outside suppliers, no dependency on third parties for critical components, everything in-house under BYD's own control. The factories are spread across several major cities in China, each with a specific role. Shenzhen is the origin point. BYD's headquarters city, where research, development, and pilot production lines test new ideas before they go into mass manufacturing. This is where the engineering decisions get made. Changzhou is where those decisions become reality at scale. This mega factory is so large, it functions like an industrial city. And a new vehicle rolls off the line every 30 to 60 seconds. Hybrid powertrain components are produced and assembled simultaneously, with robotic systems running around the clock. No breaks, no shifts ending, no slowdowns. Xi'an handles approximately 900,000 vehicles per year. This plant focuses on hybrid SUVs and sedans, the BYD Song, the Tang, and is one of the primary locations where the complete DMI powertrain unit is assembled and tested before going into a vehicle. Changsha in Hunan province runs a parallel hybrid production line combining skilled workers with some of the highest automation levels in the entire BYD network. Hefei is the newest addition. Modern infrastructure built specifically for next-generation hybrid and EV production, expanding BYD's footprint into central China. In total, BYD operates around 8 to 9 major production bases across China. Combined capacity, 5 to 6 million vehicles per year, and still growing. Now here is the part that makes BYD genuinely different from every other automaker on the planet. It is not just assembling these vehicles, it is manufacturing nearly every component that goes inside them. Engine block, motor windings, battery cells, gearbox, power electronics. Even the semiconductors that control the system, produced through BYD's own subsidiary, BYD Semiconductor. This is vertical integration at a level no competitor has matched. While Volkswagen depends on hundreds of external suppliers and Toyota sources its batteries separately, BYD has pulled almost the entire supply chain inside its own walls. Lower cost, tighter quality control, and the ability to scale production faster than anyone who has to wait on outside factories. When BYD needs more output, it adjusts its own lines. And that is not just an operational advantage, it is a structural one that cannot be copied quickly. Now let's talk real numbers, because what BYD is producing right now is genuinely hard to wrap your head around. BYD launched the world's first mass-produced plug-in hybrid in 2008, the F3DM, years before most Western automakers were even seriously discussing the technology. By 2026, total cumulative PHEV production had surpassed 7.7 million vehicles. No other company is close to that number. In 2025 alone, BYD produced and sold more than 4.6 million new energy vehicles. And here is what caught the industry off guard. In multiple months of that year, hybrid sales actually exceeded pure EV sales. Not because consumers couldn't afford full EVs, because the DMI hybrid offered something a full EV still cannot. Complete range freedom with an EV experience in everyday driving. A single DMI powertrain production line back in 2021 already had capacity for 500,000 units per year. Today, multiple lines run simultaneously across different facilities. Total annual DMI output is now in the millions. At Changzhou, the numbers become almost cinematic. A car every 30 to 60 seconds, 24 hours a day. Automation levels across BYD's top plants reported at 97%. That means 97 out of every 100 assembly tasks are handled by machines. Human workers monitor systems and manage exceptions. The machines do the building. After 2022, BYD stopped producing pure petrol vehicles entirely. Every car it builds is now either fully electric or plug-in hybrid. Every factory, every robot, every production line, dedicated exclusively to new energy vehicles. The result? Production records broken consecutively, year after year. Walk through the production process, and you understand how BYD maintains quality at this kind of volume. It starts with raw materials. Steel, aluminum, and specialized alloys arrive at the facility. 2 parallel tracks begin immediately: casting and forging. In casting, molten metal is poured into precision molds to form the basic engine block shape. In forging, metal is compressed under extreme pressure, increasing its structural density. Both processes are fully automated. The engine itself is BYD's 1.5-litre Xiaoyun, designed from the ground up to live inside a hybrid system, not to operate as a standalone unit. Its thermal efficiency reaches 43%. For context, a typical petrol engine sits between 25% and 35%. The Xiaoyun converts significantly more fuel energy into useful work and wastes significantly less as heat. From casting and forging, the rough engine block moves to CNC machining. Computer-controlled cutting tools work to tolerances measured in microns. Cylinders bored to exact dimensions, surfaces ground flat, oil channels and cooling passages drilled, checked, and pressure tested. Pistons, crankshafts, and connecting rods installed by hydraulic torque systems applying identical force every single time. Because in a hybrid engine, mechanical precision is not optional. Then comes the EHS unit, the electric hybrid system. This is where BYD's engineering separates itself. The drive motor and generator motor sit together in one compact housing. Motor windings assembled on a dedicated automated line. Magnets positioned with precision tooling. Cooling circuits built and leak-tested before integration. The completed EHS unit is then mated to the engine, along with an inverter, reducer, and central controller, forming a single integrated powertrain compact enough to fit cleanly under any standard vehicle platform. The Blade battery pack, assembled separately, connects to this powertrain along with the battery management system, which monitors cell temperature, charge levels, and energy distribution in real time. Before any unit leaves production, it runs a full bench test sequence: power output, fuel consumption, thermal performance, vibration, acoustics, and full electrical validation. Anything that fails gets pulled for rework. Only verified units move to vehicle integration. Once the powertrain is installed, the finished vehicle runs a dynamometer test, simulating real-world driving loads at multiple speeds without moving an inch. Then water ingress testing, software calibration, final inspection. Nothing ships without passing every stage. DMI is not just another hybrid system. It is a fundamentally different philosophy. And the difference matters. Toyota's hybrid synergy drive is engine first. The petrol engine does the primary work. The electric motor assists when needed. Even in city traffic, the engine cycles on and off repeatedly. It is a proven, reliable system, but it was designed in a different era, around a different set of priorities. BYD's DMI is electric first. The electric motor drives the wheels by default. The battery provides the energy. In normal city driving, with a reasonable charge, the petrol engine doesn't activate at all. The car is silent. Instant torque. No vibration. An EV experience, without being an EV. When the battery drops below a set threshold, the petrol engine starts, but it does not drive the wheels directly. It drives a generator which produces electricity that either feeds the motor or recharges the battery. And, critically, the engine runs at a fixed RPM, locked to its most thermally efficient operating point, not varying with road speed, not wasting energy at the wrong part of the power curve, just running at 43% efficiency, constantly, exactly where the engineering intended. When full performance is needed, hard acceleration, highway overtaking, both the engine and motor engage simultaneously in parallel mode, delivering combined output that neither could produce alone. The real-world results? Fuel consumption of 4 to 5 litres per 100 kilometres in mixed driving. Electric-only range of 80 to 100 kilometres on a full charge. Total range on combined full tank and full charge exceeding 1,000 kilometres, and in models like the BYD Chin approaching 2,000 kilometres. And maintenance costs reduced because the engine runs fewer total hours, cabin quieter because most driving happens in electric mode. Toyota's system is dependable, but BYD's is more modern, a larger battery, a more powerful motor, an engine that works smarter rather than harder. DMI gives you EV driving in the city and petrol freedom on the highway. The software managing the system decides automatically which mode fits the moment. No driver input required, no compromise necessary. Walk into a BYD plant today, and it does not look like a traditional car factory. It looks like the future, already running. Robotic arms lift engine blocks, fit battery packs, weld structural components, route wiring harnesses, repeating the same motion with identical precision, thousands of times per day. Automation above 90% across BYD's top facilities. At some specific lines, 97%. One worker monitors multiple robots simultaneously. Speed that manual labor cannot approach. Error rates that manual labor cannot match. Quality control operates at the same level. AI camera systems and laser sensors scan every component at every stage. A dimensional deviation of fractions of a millimeter triggers an immediate alert and stops the line. Digital twin technology creates a complete virtual replica of each production line in simulation. Engineers test new configurations and identify failure points in software before making a single physical change on the factory floor. Problems get solved before they exist. Engine testing, battery performance checks, and full powertrain validation all run through automated systems feeding real-time data to the cloud. If any metric drifts outside specification, the line stops and the issue is resolved before another unit is built. The challenges are real. Lithium, nickel, and cobalt prices move with global commodity markets and geopolitical forces that no single company controls. Trade tensions between China and Western markets create policy uncertainty. Local content rules in Europe add complexity to every expansion plan. BYD's response? Upstream mining partnerships across multiple regions, expanding battery recycling to recover critical materials, and designing the next DMI generation to work with sodium-ion chemistry, reducing lithium dependency at its source. Global expansion is already moving. Assembly plants operational in Brazil, Thailand, and Uzbekistan. Factories under construction in Hungary and Turkey. Core powertrains still ship from China, where production depth is unmatched. Full local powertrain manufacturing in these regions is the next phase. The next DMI generation pushes further. Electric-only range past 100 kilometers, total range beyond 2,000 kilometers, a smaller, more efficient engine, over-the-air software updates that improve energy management on vehicles already on the road. So a car built today performs better 3 years from now than it does on delivery day. Toyota is accelerating its hybrid development. Tata is rethinking its electrification strategy. Tesla is watching the hybrid segment numbers with increasing attention, because the data is clear. In Southeast Asia, South America, and growing parts of Europe, consumers are choosing plug-in hybrids over full EVs at rates nobody predicted. Range confidence matters, and in that space, BYD's DMI is currently the most capable, most efficiently produced, and most affordable option available. Every 30 to 60 seconds, another car. Another DMI powertrain. The factory does not stop. The industry is changing. BYD is not waiting for permission to lead it. Subscribe now and hit the bell. The next breakdown is already in production.